Hey everyone, today's note is on the chain rule. We're going to start up by following the example and going through the instructions on the top row here. So I'm going to expand. If you need to write out the middle step and actually write out the two brackets, please do so to make sure that you don't make any mistakes when expanding. So you get 25x squared minus 10x plus 1. When I take the derivative of that, I'll get 50x minus 10, and when I factor that derivative, I take out a common factor of 10, and I'm left with 5x minus 1. What I'd like you to think about is to see how you can go from here, the original function, to the final derivative without taking the middle steps. Give it a think, see if you can figure out a rule, see if you can see out a pattern, and then let's try it for the next one. This is the same thing as saying 2x squared plus 3 squared times 2x squared plus 3. When I expand that, I'll get 4x to the 4 plus 12x squared plus 9 multiplied by 2x squared plus 3. What I'm going to do then is I'm going to multiply each term out. And when I do that, I'll get 8x to the 6th plus 12x to the 4 plus 24x to the 4 plus 36x squared plus 18x squared plus 27. I'm going to collect all my like terms, and I'm going to get 8x squared, 8x to the 6th, 36x to the 4, plus 54x squared plus 27. I'm going to then take the derivative of that, and I'm going to get 48x to the 5, plus 144x cubed, plus 108x. I'm going to take out a common factor of 12x, and this time I'm going to get in the brackets 4x to the 4 plus 12x squared plus 9, which I know is a perfect square trinomial, and that's 2x squared plus 3 to the squared. Again, look and see what you have here at the beginning, and look and see what you have here at the end, and see if you can go from the beginning to the end without all the middle steps. If you can, you've figured out the chain rule. For this next page here, I've written out some basic functions and taken their derivatives, and hopefully it'll show you the pattern. You'll notice right now on the page that there are some things that are highlighted here. There are some things that have been entered in by hand. So if you don't mind taking a quick second, pausing the video and putting in these numbers here. It was just a slight error on the computer's part here, but that would be helpful in helping you figure out the rule. If you look originally at the group 1 functions here, here's my function, here's my derivative, my function and my derivative, so forth and so on. Hopefully you see a pattern similar to the power rule that you've got going on. But if you look in group 2, things look a little bit different, more like the question we just did at the end there. Well, what's different? Well, the thing that's different is that if this is my original function here, then my derivative is bring down the exponent, so at the n, the bracket, so f of x, the whole function, to the new exponent, which is n minus 1. I subtract 1 from the exponent, and then I multiply by the derivative of the inside bracket, so the derivative of the bracket, so f prime of x. Here's the thing that may look a little bit different than the power rule, but in fact it's the same. The reason that it is the same is that in the power rule, the only number that I'm actually multiplying by, or the derivative of the inside, has always been 1. So that's why it was the exact same. So this here is known as the chain rule. It's actually just a modification of the power rule to apply it to functions that have a higher exponent. So again, I'm going to say it, and then notice the way that I say it is exactly the way that I'm going to do it. I bring down the exponent, I multiply by the bracket to the new exponent times the derivative of the inside bracket. Okay, so let's try some examples and see how it goes for us. So if here is my function, my derivative is bring down the exponent, bracket, to the new exponent times the derivative of the inside bracket. Now you may notice here that this and this I can merge together, and I can. That's 12x cubed times x4 to the minus 1 squared. not a problem. That's simplified. I could have left it as it was, but sometimes it's just quote-unquote cleaner to put them together. Okay, let's try the next one. F prime of x, bring down the exponent, bracket to the new exponent, times the derivative of the inside bracket. Again, I could merge those numbers together and get out an even nicer number. Let's try another one here. 6 times 10, which is the bring down the exponent, so 60, bracket to the new exponent, times the derivative of the inside bracket here, which is 1. Next one, that's 7 times 3, so I'm going to write it out, 7 times 3, bracket to the new exponent, times the derivative of the inside bracket. When I make that look a little bit nicer, that's minus 336x and 3 minus 8x squared to the 2. Next one. Bring down the exponent, bracket to the new exponent, times the derivative of the inside bracket. I could leave it this way. I could also put the smaller bracket first. I could make it 6x minus 3 if I want to. It really doesn't matter. All of these are fine, and you'll, as you go along, you'll notice when you need to pull things together and when you're going to need to keep them separate. But it takes a little bit of practice, and it also takes a couple of the other rules before you sort of get why you're going to be doing it. All right, next one. Minus 2 times 5, bracket to the new exponent, times the derivative of the inside bracket. So I would merge this here, minus 10, 3x squared plus 6x, and the x cubed plus 3x squared plus 1 to the 4. Okay, now I've here put in, a fraction exponent. This fraction, again, is the same thing as if I had written square root, so I just started it out a step later. But let's try this one, a little bit more challenging. Bring down the exponent, bracket to the new exponent, negative half, times the derivative of the inside bracket. Now, how to make this quote-unquote look nicer? Well, the 1 stays on top, so does this 3x squared term here. And then on the bottom, the 2 that comes from here. And then this negative a half becomes a square root symbol, remember. And this is x cubed minus 4x squared plus 5x minus 3. That one was definitely challenging, so hopefully you got it on your own and you're just verifying. Try the next 4 on your own, see how they go for you, and then check your work. Here we go. I don't like the way this is written, so I'm going to change it to 7 times 2x plus 5 to the minus 1. Now I can easily take the derivative, so f prime of x is equal to 7 times minus 1, 2x plus 5 to the minus 2, and then the derivative in the inside bracket is 2. So that comes out to negative 14 over 2x plus 5 squared. The next one, if I change, will look like this. And if I take the derivative, that's 4, bring down the exponent, bracket to the new exponent, times the derivative of the inside bracket. Hopefully you haven't made any mistakes with the negative exponents here and that you're doing okay. Which is negative 12 over x minus 3 to the 4. Okay. Try the last 2 on your own. I'm going to put up the answer straight away and then check your work. Check your answers with the ones that are listed here. Hopefully you did just fine and there weren't any issues. The only issues I could possibly foresee would be subtracting 1 from a negative exponent. So here and here. And possibly switching this form into this form here. Again, you shouldn't have any issues. If you do, please come in for help, tackle the homework, and I will see you again soon. Take care.